Density is the amount of matter in a given volume for a substance, okay? And the cool thing about density is it should be constant at a constant temperature. So um, let's talk about that, and let's talk about the equation. So density is the amount of mass or the amount of matter, which remember mass is really a measurement of the amount of matter. So density equals mass per given volume. So let's say that we have a ruler, eraser. Let's go with eraser, like one of the chunk erasers. Okay, it has a uniform density all across that eraser. So what happens if I break it in half? Okay, I've decreased the volume by 2. But I've also decreased the mass. So it shouldn't change at all. The density of each of those pieces is the same, okay? So that's cool. You can use density to identify a substance. All right, so what should the units be? Well, um, the SI unit for mass is the kilogram, and the SI unit for volume, remember volume is just really length times width times height, and each of these is a measurement of distance, so it's meters times meters times meters. So the SI unit for volume is meters cubed, all right, kilograms per meters cubed. Now, I can almost guarantee you that we will not use this unit for density ever. Okay, it's not a helpful unit. So instead, the units that are preferred to be used are grams per centimeter cubed. Now that would be here centimeter times centimeter times centimeter. So basically, I've just divided everything. I've made everything a little bit smaller. Okay, that makes it a more reasonable set of units. Okay, now this is something that you have to memorize. Okay, 1 centimeter cubed equals 1 milliliter. All right, so if 1 centimeter cubed equals 1 milliliter, I can also say, or units would also be grams per milliliter. Now, if I look at units when they're set up like this, okay, any time that you see units like this, you should be thinking conversion factor, okay? Density is really a conversion factor, okay? And it converts between mass and volume, okay? Converts between mass and volume. So I'll show you how to solve problems both using density, the equation, and also using density, the conversion factor, okay? In this class, I think it's more powerful to do density as a conversion factor since we'll be seeing other things that look like this that we'll be using as conversion factors. All right, so here's kind of an interesting example. Match the substance with its density, okay? Well, here is a bunch of silvery liquid, which is labeled mercury. And then there's some pellets here that's called copper shot. And then there's water. All right. So one of the things that you'll immediately notice is that water is actually on top and everything else is below. So maybe, this always initially kind of messes people up because they're thinking of ice, which floats on water, or oil, which floats on water. Okay. So as the density of a substance increases, if you take two substances with different densities, the more dense substance will sink to the bottom. Okay, if one of them is a liquid, one or both of them is liquid. All right, So, so think about like a rock, right? What has greater density, a rock or water? Well, we know it's a rock, and rocks sink. So there you go. All right, so given that information, we can say that the density of water is probably the smallest density, and that's 1 gram per milliliter. That copper is the next most dense, so that would be this 8.92 here, okay? And then there's mercury, that's this guy here. Okay, now here's one more thing that you have to memorize, okay? This is very important. Memorize it, memorize it, memorize. The density of water is 1 gram, 1.0 grams per milliliter. You need to memorize that. We will use that value rather a lot, okay? So density of water is 1 gram per milliliter. All right, so here's a sample problem, and as promised, I will show you 2 different ways to solve the problem. Okay, the first one is using density as a formula. All right, so D equals M over V. So what we're looking for is we're looking for density. So that's what we're trying to find. Okay, I'm given a mass that's 853 grams, and I'm given a volume. Okay, so when you get a chemical formula like this, one of the first things that you need to do is you need to solve for the unknown. Okay, and in this case, the unknown is the density. So density is the mass, 853 grams, divided by the volume, 310 centimeters cubed, okay? And I get 2.75. Now, am I done? Well, no, I'm not done, because this number doesn't have any units. It's a naked number, okay? There is no nudity allowed at this school. You must put units. You must dress all of your numbers up with units. Grams per centimeter cubed. Okay? Now, when treating density as a conversion factor, sometimes what you might have to do is you might have to actually create your conversion factor. And so I know that what I want is I want density, which given my units is going to be in grams per centimeter cubed, okay? Because those are units of density. So then I just fill in. This is 853 grams over 310 centimeters cubed, and I get 2.75 grams per centimeter cubed. Okay, so these are 2 different ways of approaching the problem. Granted, with this one, not real interesting that they're different, but on future ones, it'll be a little bit more, it'll make a little bit more sense that how they're different, okay?